Solving simultaneous equations by substitution. We want to solve the following simultaneous equations by substitution. Let's call this equation 1 and this one 2. Note that this one's nicely set up with x being equal to 4 minus 3y. So I can substitute 1 into 2. So what I'm going to do there is the x here in this equation, I'm going to replace it with 4 minus 3y because I know that that's equal to x from equation 1. So we're going to write down 4 minus 3y and then equals 6. Now if you look at this equation carefully, you'll see that it is equation 2, but just with the x replaced with 4 minus 3y. Now I'm going to expand the bracket. Note that that's a negative 1. Negative 1 times 4. Then negative 1 times negative 3y is a plus 3y. Tidying this side gives me 5y. Take away 4 equals 6, and now I just need to solve this. So take the 4 to the other side, 5y is 10, and y is 2. We then sub that into 1, and x is equal to 4, take away 3 lots of 2, so that's 4 take away 6 is negative 2. So our final solution is that x is negative 2, and y is equal to 2. Now here we have equation 1 is y is x plus 5, equation 2 is y is 7 minus x. Now note that both equations are y equals. So if y equals this and y equals this, then these must be equal to each other. So let's say that that's sub 1 in 2. So what we're going to do is we're going to write down equation 2, but instead of y on this side, I'm going to put x plus 5. Now we just need to solve this, so if we add x to both sides, that gives us 2x plus 5 equals 7. Remember, if we add x to this side, the x's disappear. Subtract 5 from both sides, 2x equals 2, giving us x is equal to 1. Now we can sub that in either of the equations, so sub in equation 1, then we get y is equal to 1 plus 5, which is 6. So our solution is x is 1, y is 6, and of course we should be able to verify that by substituting into the other equation, the one that we didn't use, just to make sure it works. So here we have y equals x plus 6, and 2y is 15 plus x. So 1 is nicely set up with the y equals, so I'm going to sub 1 into 2. So instead of having y here, I'm going to have x plus 6. So that's 2, x plus 6. I need the brackets because the 2 needs to multiply the whole of the x plus 6, is equal to 15 plus x. Now look carefully at this, and carefully at equation 2, and you'll see the difference is that the y has been replaced by x plus 6. Now expanding out, we get 2x add 12 is 15 plus x. Subtract x from both sides gives us x plus 12 equals 15. Subtract 12 from both sides gives me x is 3. Now the easiest place to sub that is 1. So sub in equation 1, and we get y is equal to 3 plus 6, so y is equal to 9. And therefore our solution is x is 3 and y is 9. And of course we can always verify a solution. Now if we look at this one, it's actually much better set up for another method called elimination. So I wouldn't do it by substitution unless told to do it by substitution, which we are here. So let's call this 1 and call this 2. And then I'm going to say that 1 gives us that 6x is equal to, and bring the 7y to the other side, so it will be 7y add 31. So let's just call that equation 3 for now. And then what I'm going to do is multiply equation 2 by 6. So that gives me 42 x's add 36 y's is 6 times 22, which is 132. But this one here is 7 lots of 6x, 7 times 6 is 42, add 36y is equal to 132. And then what I can do there is replace this 6x with 7y add 31. So 7 lots of 7y add 31 add 36y is equal to 132. So that's 49y add 227. That's not right. Seven times 30 is 210, and then 7 times 1 is 7, 217. Add 36y is 132. Now the chances are you wouldn't have this sort of thing without a calculator, but I've not got a calculator at the moment, so I'm just going to go ahead and work out how many y's I've got. So that's going to be 15. So that's going to be 85. So I've got 85 y's. And doing 2 steps at once, shouldn't do that. 85 y's add 217 is 132. So 85y is going to be 132 take away 217. So 217 take away 132. So that's going to give me 5. Need to borrow one from here. So that's 85. So this would be negative 85. And so y is negative 1. Now, let's substitute that back to here. So we'll sub in 3. And that would give us that 6x is equal to negative 7 add 31. So 31 take away 7 is 24, giving us that x is equal to 4. So we've got x is 4 and y is negative 1. So let's verify these solutions. So if we look at our equations, we've got 6x minus 7y is 31. And we're checking with these values. So we've got 6 times 4, take away 7 lots of negative 1, is going to be 24, add 7, which is equal to 31. So that works. And then we've got 7x plus 6y is 22. So 7 lots of 4, add 6 lots of -1 is equal to 28 take away 6, which is 22. So that works as well. So we know that these are correct solutions.